Thank you. Yeah, after some technical issues, we can start. Hello, my name is Andrey. I'm from Riga, from neighboring country. I'm actually here just for vacation, and decided why not to give a talk. So yeah, here I am. So a few words about me. I am developer at heart. That's why I'm basically doing the things for DEVCLUB. But many people know me as a DevOps guy. I mean, for the last 15 years, I'm probably doing a lot of stuff related to DevOps. On the other hand, I'm still a developer. I still write a lot of code. I do a lot of stuff with software. Also, recently, a couple of years ago, I started as a CTO, as a fractional CTO for the company, where I actually also faced a lot of issues with security. And I mean, when you're working in a technical company with software developers and sysadmins and people who are very technology aware, that's one set of problems that you get. But when you start working in a company where you have normal users, it's a completely different set of problems. You see lots of issues that you haven't seen before, like basic stuff that they open the link that no normal developer will ever open, but they open that and they get hacked, and that's a lot of stuff gets happening when you see different perspectives. Right. So, but here I would like to talk about supply chain attacks and about how to protect that, and of course I would like to talk about that in the lens of DevOps and DevSecOps in general. So, what's supply chain? Well, we all know, I guess. Most of us should be technical people here, and supply chain is obviously everything that is involved in delivery of software products, right? Devices, computers, laptops, phones, services. Vendors that we work with, like, libraries, tools, pipeline, everything basically that is involved in some way of managing and developing and delivering software, right? It's all part of the supply chain. And every element can be attacked, obviously. And every element will be attacked. Rest assured, it will be attacked because hackers are looking for the best way to find the easy money, and the weakest point in this supply chain, of course, will be exploited, and maybe they will get what they want. Right. But since I'm talking from the perspective of DevOps, do you know this term? Have you heard of that before? Wall of confusion? Right. So it's actually a pretty old concept. Well, compared to other technologies, maybe like AI. Basically, well, that's from where DevOps started, right? Devs and ops on different sides of the software delivery. Software developers and sysadmins, they were sort of in the war, and there was a wall of confusion between them. And DevOps was about to solve that, right? So we have devs on one side, they're throwing applications to the other side, and those poor sysadmins don't know what to do with that, and there's lots of confusion. Of course, from security perspective, that's bad, right? And DevOps was about to solve that, so that we bring together the operations, and that's why things like Kubernetes and cloud native were born. And pipelines for delivery of software. So we bring the problems that were operational problems, we bring them closer to where the software is created. So we close the gap. And actually it's also called shift left. And the same idea is actually coming to security. That's why you probably have heard the term DevSecOps, right? So we're trying to solve the same problem because basically we have a development team, we have a sysadmin team, and we probably have a security team, right? And there's not enough conversations happening between them. And that's why this idea of shifting left. So we bring the feedback cycle closer to where the software is being created. So because it's cheaper, it's faster, it's more reliable, and it gives some extra benefits from there. Right? Have you heard about shift left? Anyone? Okay, some of you. Right. The first question to you folks: do you have a security team in your company? Like 5 people, 7 people? 8 people, okay.
What is team?
Team is a group of people with the same goal. Okay. The question is to those who have a security team, how often do you talk to them? Have you seen them actually? Do you? Yes. Well, you're from Microsoft, so I guess at least in the last events you had to talk to them at some point. Right. But yeah, the thing with security at the moment, the picture that I see in many companies is that security is a separate team that is working somewhere, maybe in a different building, in a different room, and nobody interacts with that until there's an incident, right? And that's definitely a bad situation, right? Because what I believe is security is everyone's responsibility. So you cannot fix security with the security team. Of course, security team is important, no doubt about that. But if your developers are not caring about patching the software with the latest versions, with patched versions, stuff like that, then you never will be secure. If your sysadmins don't care about protecting the network, you never will be secure. So basically, the idea here is everyone is responsible for security, and we have to raise awareness. The best security setups or like security culture that I've seen in a couple of my clients is that security team is there, but it's not there to block things. It's not there to, do something in secret, but it's there to facilitate and educate other teams, other people in the process. Because without that, obviously, if you don't talk about security in the company, then security will always become an afterthought, right? It always will be the topic they will discuss only when there is something bad happening, not when there is something, no business as usual, right? So that's why it's super important to do that. Yeah, and software delivery is a complex process. We have lots of components, and I already mentioned, different elements of the supply chain. When we talk about DevOps, we also often talk about, pipelines and the different tools involved in that. And of course, every one of them is a potential security attack vector. It's a potential place where attackers will actually try to integrate into your company and steal some data and do some stuff with that. Right. Another thing to consider is that security is also a responsibility that you can partially delegate. And let's say when you are an architect of your software product, or you're an architect of a big company, or you're a CTO, for example, you have to make the decision to whom you delegate your security, right? And I mean, in some cases, like if you're building a completely unique product that needs unique hardware and unique capabilities, networking and stuff like that, maybe for some legal reasons, then maybe you would like to have the whole stack. But of course, when you do everything in your company, like you do your own networks, your own storage, your compute, of course you have to consider that the security of these elements is your responsibility. If you're using, let's say, some cloud service like Amazon or Google or Microsoft, then you can delegate part of that security to the vendor, right? So let's say Microsoft Azure or Google Cloud can actually control that for you. Of course, you have to trust the vendor. You have to, of course, maybe read their security newsletters from time to time. But in general, in that case, security, of course, is still your responsibility to some extent, but part of that is delegated to another vendor. And you can go up the stack and delegate more part of that. But it should be your decision. It should be your acknowledged decision that you select different parts of the stack to be controlled or secured by a different party. Okay. Now, let's talk about attack surface. Everybody is familiar with the term, right? That's basically, you have to determine what's your attack surface, right? Because depending on what kind of software you do, what kind of services you provide and stuff like that, your attack surface will be different. Of course, for majority of developers, the attack surface pretty much is summed up on this slide. So we have the application, maybe have the runtime, something like Java or Python or whatever. We have maybe the container engine, which is quite a common thing, and we have the actual server. Right? And then the rest, we have the network, we have other bigger systems. But it's quite important for everybody to understand which parts of your software, of your services, of your products can actually be attacked. And how well they are protected. Because what I see quite frequently is that not every person in the team realizes that, for example, the biggest issue, for example, in this specific team is actually running in the runtime, is appearing in the runtime. For example, if you take PHP, and if you like running PHP, I don't know, 5, That's super vulnerable thing, right? And if your developers say you differently, then they are wrong. The same thing goes with Java, for example. If you run Java, I don't know, 7 for some reason, which is pretty old Java, then you have lots of issues with that. Of course, if you run Java 21, there still could be some problems, but in general, it's much better set than Java 7, Java 8. Right, so now let's dive into different attacks or vulnerabilities or outages that happened recently. And let's just try to discuss some of them. Maybe you've heard about some of them, maybe not, but let's discuss them. So, Heartbleed. Anyone? Who have heard about Heartbleed? Okay. It's old, it's very old. It's like 10 years old. Shell shock? Few people. It's also very old. It's about the same time, maybe like 9 years or so. But it was very huge. Actually, the cool thing about these first two, they actually have their own websites. So if you go to heartbleed.com, you'll find information about Heartbleed. The same thing with Shell shock. The ones that actually gave a lot of trouble to many cloud providers is the two, Meltdown and Spectre. Heard of that? Yeah, a few people heard of that. And the hardest part of them is that actually they are in hardware. It's a vulnerabilities discovered in Intel processors, and that gives a lot of headache. They gave a lot of headaches to anyone who actually owns a lot of infrastructure, especially to the cloud providers. On the other hand, if you are not owning any infrastructure, like physical infrastructure, you only run things from the cloud, then obviously it's not your responsibility to fix this kind of bugs. You delegate the security to the cloud provider, which is good. But vulnerabilities can happen everywhere, and potential attacks can happen everywhere. And these two things, they are super dangerous because basically, especially in the cloud environment, if someone has created a VM, virtual machine, inside the cloud environment, then they potentially can get access to any other machine running in the same physical machine inside the cloud environment, which could be anything. And that's, it's not maybe super dangerous in terms of that you cannot guarantee what kind of data they will get. But occasionally or accidentally, they can get something very, suspicious and secret. Right, okay, let's talk about this three first. Log4Shell, anyone? Any Java developers here? Okay. Yeah, let's talk about that. Oh, no, it's not a real one. I guess everybody's seen that screen recently. Was anyone affected by this? No, you're not using CrowdStrike, right? I was actually quite surprised because nobody I know in Riga was actually affected by that, because apparently we don't use CrowdStrike it's an endpoint protection mechanism. And you probably have heard of that they released a new update, and all the machines that were using CrowdStrike software, kernel driver for Windows, were actually crashing. They couldn't start up, right? And you can see that markets reacted to that very harshly. So yeah, they lost like 30% of their stock price because of that attack. So right, let's talk about Log4Shell. So Log4Shell, actually, there's a lot of things to learn about what to do to protect your environments just from looking at the potential path the attacker can take, because basically everything that could go wrong there could actually be protected by very simple measures. So, Java developers here, do you ever use GNDI? Anyone? So basically, the last time I used GNDI was like today, or maybe a couple of weeks ago. Yeah, because the funny thing with Log4Shell is that, Log4j is the library that was using that, is that GNDI is part of the Log4j like forever. It's like for I don't know, 2 decades in there. I don't know for how long. But the truth is that nobody in Java world is using GNDI for real for like at least a decade. But the code is there. The code is there, and it's usable, it's invocable, right? So basically, the attacker could construct a request, HTTP request, either through a URL or through maybe injecting a header into the request. And if that request contained, this injected expression with GNDI URL, then the vulnerable Log4j would invoke the URL and go to the attacker's server. And I mean, this could be protected by some input validation, which could be implemented like in no time, and most likely most of the libraries actually already had that, like web libraries have that. Also, invocation of unknown port or unknown traffic pattern from internal network of the company is something that you can protect with simple network policies. But nonetheless, Log4j or Log4Shell actually was a huge disaster for many enterprise companies, because I think, I don't have numbers, but probably 60–70% of all big enterprises actually use Log4j, and they had issues with updating that. Actually, I had a client where they had lots of applications running in production, Java applications, and several of them were using Log4j, but for some of them, they didn't have the source code in the repository, so they couldn't rebuild them in order to fix the library. And that was really a disaster. So yeah, but the attack itself is very serious, because it's a zero-day attack, right? It was there since the very early versions of Log4j. So basically, any program that is using Log4j would actually be affected. But on the other hand, there's a lot of mitigations that you can apply to input validation, to network policies that could easily defend you from this kind of attacks. But it was huge things. And the other question here is, because LDAP and JNDI stuff, that was this part of core library of Log4j. The question is, why is it there if nobody is using that, right? And basically it leads to this question. Unused code, is it evil? And sometimes it is, right? So just when you get back to your source code, like on tomorrow, think of that. Is there some code you can actually delete? Something that you actually don't use? Because unused feature, unused code can lead to this kind of things eventually. Right, so what can we do? Yeah, we block the traffic or only allow the traffic that we know, and we also probably have to have something in place to do anomaly detection, because this is not a normal thing. The funny thing about Log4Shell is that if you look at Docker Hub, I guess everybody knows Docker. No need to explain that. If you look at Docker Hub, they have this special sign there: Log4Shell not detected, right? But the funny thing is that this is a Python image. Obviously, Log4j is a Java library, and it's not present in any of the Python images. But still, the splash was so big, the panic was so big inside the enterprise, the Docker Hub or the Docker company decided to put the sign on every repository in Docker Hub. So yeah, it's kind of funny how big it was. Maybe companies were more scared than they should have been scared. Okay. Anyone heard of this one? Yeah, this is a pretty recent one. It happened this year. And this guy actually is quite interesting from the perspective of how long it actually took from the hacker to get into, to actually create an attack, right? Sorry. So basically, there's a common issue with open source libraries, and exat is basically it's a compression library which is being used by pretty much every Linux kernel on the planet, every Linux distribution on the planet. And as it happens, it only has one maintainer, right? Last Colin is the only guy who is maintaining the library. So in 2021, there's another guy who actually, he's not known anywhere except that repository. He created a GitHub account, and he started to help Lasse to actually to do some patches, do some pull requests. And you see, it took him like 2–3 years to actually commit an attack. And of course, he obfuscated that. He actually pretended that is a test, and then initially he put his data into gitignore, but then he removed the gitignore value, and the actual test data was sort of dumbly encrypted so it's not recognizable by any code analysis. And actually, the other thing that he did, I mean, we don't know for sure, but there was another guy or another account that around the same time, like to 2023, 2024, was actually actively participating in the PRs, in pull requests, by commenting them, saying that, oh, it's such a nice feature that you committed, Gia, we need to push it forward, blah, blah, blah. You know, it's a total social engineering, and actually it's amazing how much time the guy or the group of people actually spent trying to feed that hack, that attack into the library. Because, and actually they almost succeeded. They almost succeeded. And thanks to this guy, actually he's working at Microsoft, he noticed that there's some strange profile, the memory profile, when you run this new code, new updated code, and it's just using too much memory, not as much as usual. And he actually found out that it leads to this library, and he reported that, and then it all started. But it was like only a few days away from this library being pushed to the upstream, to the main distribution of Linux on the planet, and within, you know, I don't know, a few weeks. Many of the distributions, many of the Linux machines would be infected, right? So that's really fortunate that we actually, you know, caught that. And I mean, the way to mitigate these kind of things, I mean, it's sort of impossible, right? Because obviously, probably big companies who are supporting operating systems, they probably should invest more time or money to support poor maintainers of the libraries. But in general, of course, it's very hard to detect this kind of guys, right? And yeah, most likely it was maybe it was a government actor, like, you know, somebody from North Korea or China, because it's, you know, it's a lot of preparation. Right. Have you heard of this one? SolarWinds, anyone? Yes. Okay, some of you. So with SolarWinds, it sort of was similar. Attacker also used a lot of time to actually, you know, do a lot of bad things in the network of this company. SolarWinds is a company producing monitoring software. It's called Orion, and they were quite popular at the time. I think they had like 33,000 customers that were using their software, and attacker managed to get in the infrastructure of SolarWinds, right? So they managed to hack the virtual machine that was releasing updates to the customers. They spent quite a lot of time on that machine, to be honest. So it's in 2019, in April, they managed to hack it. Only in November, they tried to deploy a test code to the customers, and they succeeded. And then in the next year, in February, they actually deployed the spyware, right? Then at some point in the middle, hacker actually removed his hack from the release machine, but still the spyware was already deployed to, I don't know, thousands of customers. And only in December of 2020, like a year and a half after the original hack, it was detected, and it was actually a huge alert because many of the customers of SolarWinds actually were government institutions, some public entities, which could lead to, you know, some bad things happening, like, you know, state secrets being stolen and stuff like that. And there is a suspicion that you know, it actually was, again, some government actor, like, you know, Russia or North Korea or something like that was actually doing that. And you see, the main problem here is that this guy was unnoticed for a year and a half, maybe even more. We don't know. We don't have the data, and we don't have the official report for that. Right. So nobody used SolarWinds? It's probably, it's a good software. I mean, it's a quite okay software. I actually have a client in Denmark which used that. They were not affected, but yeah, it was a bit of a few weeks of panic when they realized that they might have been hacked as well. Right. So again, here the mitigation could be that we have to monitor the network traffic. We have to understand what kind of things are outgoing from the network, and maybe do some log analysis, maybe do some login analysis to see who is logging into our servers and stuff like that. And that's what SolarWinds should do. Right? So actually, that was any respected software vendor should do. They should protect their release pipeline, their release channels as their only child, right? And you know, the same thing happened with CrowdStrike. I mean, CrowdStrike, it's, of course, it was not an attack, but it was definitely it seemed like an attack to everyone who actually was affected, right? Especially those who were like flying to some like to the States or from the States or to the UK from the UK. It seemed like, you know, somebody intentionally did that to them, right? Browseraluod, anyone heard of this one? No. Well, actually, it's a less known thing, but it's interesting the way it was kind of distributed. Of course, again, it was a library vendor. Browseraluod, actually, it's a library to automatically read the contents of the website. It's a JavaScript library. And it's really useful, right? It's especially for disabled people with hearing issues and stuff like that. It's very nice library, and that's why lots of government institutions actually were using that library to help their citizens and stuff like that. And apparently, attacker managed to hack the S3 bucket, like the delivery mechanism for the JavaScript library, and the users of the library, the people who are developing websites that use the library, they didn't notice that. They just, you know, we trust our provider, so we just, you know, use the latest version from them. But somehow, attacker managed, you know, to replace that. And of course, it was loaded by the web browsers of users. Actually, it was like thousands of users, if not more, if not like tens of thousands. And the funny thing, I mean, it happened in 2018. And maybe if it happened now, it would be a slightly different type of attack. But since it happened like at that time, the first thing that most of the hackers do, they actually try to Bitcoin, do mining for the Bitcoins, right? And they did that with the JavaScript library running inside end clients, like web browsers in the phones, web browsers on the desktops. And that's crazy. I mean, like, could you ever imagine that Bitcoin miner can run on your phone in the browser? Yes, it can. So, and of course, there was an analysis done on that attack after that. They didn't earn that much. They probably like $50 and stuff like that because it was noticed in time. But still, and again, the way it was caught is that some of the browsers that were running inside more protected networks with some plugins installed, they noticed that this website suddenly started using too much memory or too much CPU. And they started investigating and they found out that something is wrong with the website. But yeah, it took some time. And that's crazy because, you know, if this thing happened now, then most likely they would not do the mining. They would probably try to steal some credit card data, some I don't know, some personal data, some social security numbers, stuff like that, and that would be not noticed. Because the only reason it was noticed because CPU was up. Otherwise, we don't know. Maybe somebody's already doing that for some other websites. Right. And I will share the slides later on. And there's a nice video that is actually explaining what happened and how was it found. Again, what can we do about, you know, this kind of attacks? Obviously, there should be some network activity analysis, and maybe we should also have some endpoint security analysis, like, you know, something like CrowdStrike, but for browsers, right? And the browser should actually, you know, tell you that something is suspicious going on about this website and do something about that. They already do, but it depends on what kind of software you use. Yeah, of course, another thing that should happen, of course, you should sign the artifacts. Because the main mistake that the vendor and the clients, the companies who are developing websites using the library, the main mistake that they did was that they just relied on the latest, which you should never rely on. And you should always verify that the thing that you're actually serving to your customers is the authentic thing, right? It's not coming from some unknown place. So signing of the artifacts and verifying that it's authentic, it's super important. Because you don't know, especially if it's coming from someone else. Yeah, let's go to this guy. I guess everybody's familiar, NPM. JavaScript, and yeah, actually it's full of these kind of libraries. And I mean, well, Browseraluod is one thing, but it was kind of sort of developed by the vendor and provided to you by the vendor and was kind of a different thing. But here we have a public library, free library, open source library, and again, the attackers managed to inject their code into the very popular library. So it's, again, they used the fact that open source developers really are underpowered, and they really sometimes lose they don't have enough attention, and they can be actually used to inject some malicious code. So this is one thing. Another thing, which actually is not really an attack. Have you heard of leftPad? I guess some of you. Yeah, it happened in 2016, so again, a bit older. But for a few hours, when it happened, for a few hours, nobody could actually build, well, not nobody, but some people could not build, many people could not build their front ends and back ends that it was using Node.js. Because as it appeared, the author of the library, he removed that from NPM. And the reason for that, actually quite stupid reason, well, this guy, Andrey Adamovich, he's originally from Turkey, but he lives in the US. And he actually created I think he was 200 something packages that he published on NPM. And one of them was leftPad, another one of them was Kik. And Kik was also, as it appeared, it was also the name of some messaging app in Canada. And those guys decided that they own the name. I don't know. Maybe, and they asked, first of all, they asked Azure to remove it, and then Azure declined, and then they asked NPM, the company who is actually managing the repository. They asked them to remove it, and well, these guys agreed to remove that. Azure was very angry, obviously, and he removed every library that he ever wrote from NPM. And as it appeared that this 11 lines of code caused a lot of build issues on the whole planet. Because people were using this leftPad because it apparently was a very useful library. I mean, leftPad didn't do much, right? It's just doing the left padding, just adding spaces in the strings, so it was not really useful, but yeah. And you can read the full story on the link. And the funny thing is that NPM actually is full of these kind of libraries. Do you know what this library does? Well, it's odd, right? It's a very odd library because it's just checking if the number is odd. I'm not sure how big is the code base, but what is scaring is that it's actually downloaded quite a lot of times a week. Right? And actually, there's another package called isEven, which is calling isOdd. So yeah, it's kind of funny. The other thing that actually exists in NPM, it's a package called hyphen, the minus. You can check, it's there. and the reason it's there, I guess, is because whenever you type something like npm I minus or hyphen and press enter, or you have some extra spaces between the hyphen and the next parameter, this package will be installed. So it's actually quite easy to get some, well, this code is not malicious, there's nothing dangerous in that, but just think of that. It's so easy to trick developers into installing something that can potentially be dangerous. And I mean, it could also be that it's not your problem. You're not the endpoint of this dependency tree, but maybe it could be someone else who actually, accidentally typed npm and I minus and typed a space and put it in the package JSON, and then by extension it could be in quite many places. So you see, still quite scary, right? 15,000 times a week, somebody gets that package. What's there? I mean, yeah. So what can we do? Yeah, so dependency tree, of course, it could be a very dangerous thing, and obviously we don't have to use stupid libraries, or the libraries that use stupid libraries, or the libraries that use libraries that use stupid libraries. So that's a challenge.
What is stupid? What is stupid?
I mean, dangerous libraries, or things that potentially can become dangerous. Because at this point, if you look at the code, it's probably not that dangerous. But if at some point the author of the library will decide that, okay, now I have enough installations, let me kind of use it. then it will become dangerous. Then it will transform from stupid to dangerous. And you never know. You never know when it happens. And actually, if you look at the NPM, you will find pretty much a library for every NPM flag, NPM command flag in there. Because obviously, somebody is either like trying to be funny or dangerous, or we don't know, right? But it's there. It's there. The other thing we can do potentially to protect ourselves from this kind of stupid stuff is, of course, do vulnerability scanning for the libraries that we get. And maybe in some cases have a cache, like with the leftPad. It would help to have a cache in your local repository somewhere so that you don't depend on the outside world being down. Right, so what else? What else can I tell you about that? Is that in order to protect yourself from a lot of stuff, not just the ones that I described, you probably have to do SBOM. Anyone knows what SBOM stands for? 1 guy, 2 guys, 3 guys, 4 guys.
Is it Java bomb? Or is
No, not at all. It's software bill of materials.
it's partly related?
To some extent, yeah. I mean, bill of materials is something that you usually use in construction projects, which basically lists all the things that you used, to construct, as a building or a factory, stuff like that. And software bill of materials is sort of the same thing, right? It's a list of things we use in order to, do something useful with our software. And of course, this extends to the statistics about how many vulnerabilities each of these dependencies may have, and the dependence of the dependencies, and also how many, what kind of licenses they use and stuff like that. And actually, software bill of materials, I mean, it's something that was known for a couple of decades, but in recent years, especially when COVID sort of hit in, we started to use more and more online services and a lot of that stuff. There's gained sort of a new energy, and lots of people starting to look at that with even more attention, right? It's an important thing. There are many tools that kind of exist for this kind of domain. There are many formats as well. The one that I prefer is the last one, Cyclone.exe, but of course there's some other ones that are mostly proprietary or used in some specific areas. The one that is kind of sort of popular is OWASP, right? And there is this guy, which I'm actually using quite frequently now in different clients, to collect information. I mean, it will probably not solve your security issues, but at least it will allow you to see the full picture of what's happening in your software project. And I mean, SBOM format actually is very simple. It's basically, there's name of the library, list of the dependencies, their versions, their licenses. So it's actually a very, very dumb format. But it could be very useful when you visualize that, when you monitor that, when you collect, information about vulnerabilities and try to do some analysis on top of that. And you can also expand that because, quite often it's easy to collect information about vulnerabilities from public repositories like NPM or Maven. But if you have your own internal software libraries or software components that you create, then usually there's no information about that because it's your project, it's your libraries. But you can extend SBOM to actually contain information if you need that, especially if you're like a big company that does a lot of stuff. The other thing that I guess many of you folks know, SAST or SCA, or basically static analysis, right? Analyze the code, right? And I mean, these guys existed for, I don't know, at least 4 decades as far as I know. Some of the oldest static analysis tools that I've heard of. Most of them are, scanning for code issues, but many of them also have focus on security, and they can catch, some of the obvious issues with input validation or file tree navigation, something like that, or basic stuff that most of the developers should know about, but sometimes forget about, and these tools can actually catch some of that. And the 2 types of SAS tools, you probably know that as well. We have static analysis and we have dependency analysis. And that's what, SBOM can also help with that. I will not talk about these guys, but the cool thing about SAST is that, or static analysis in general, is that we can detect early stuff. We can easily integrate that into any automation, right? And we can easily scale that. It's kind of easy to run lots of analysis tools on a big code base with some simple tricks. The problems, though, that I see a lot is that they often also produce lots of false positives, especially if you ever use something like SonarCube or something similar, and you run against a new code base that you never ran before the SonarCube on, you will get lots of warnings. And that's what quite often puts off the developers, especially when you already have 200 tasks in Jira, and then suddenly you have another 10,000 warnings. Obviously, you will not fix them, right? Because it's just too much. It seems like a lot of noise, and there's no real value in that. So my approach to that is usually that I'm trying to, first of all, of course, focus on the critical ones, right? So we enable the rules, but we not enable all the rules. We enable only the critical rules and blockers, and we try to fix them. And it sort of also works as an educational tool. Because if you enable all the warnings, then nobody will look into that. But if you enable 1% of the warnings and you actually talk to the team and try to discuss with them how to fix that and why it's critical, not critical, then they will actually be, first of all, educated. They will know why we're doing that. They will actually, the next time we see this kind of errors, they will actually be faster to fix that. So it's important to not just enable the tool, but also spend some time on configuring the minimal viable number of warnings, and also spend time on explaining and working with the team to actually fix them. Right, because otherwise, yes, it's just be a lot of noise, right? The other problem with SaaS tools is that they are quite often they don't take the context of your environment, of your organization into account. So, for example, quite often you will get a report on the vulnerabilities that are related to some library, but for sure that you don't use that library, just part of the dependency, use part of the library, like for example Log4j. Because you're already protected on some other level, like in network level or some network policy level and stuff like that. And you know that certain types of problems will never occur to you because you're already protected. And these kind of tools, they don't know that. They just report you based on the just the code that you have. And that could be sometimes time consuming. And again, one of the reasons why people stop looking at them. Also, there's no guarantee, of course, that this code going to be secure after you fix all the warnings in SonarCube, for example. The other approach, DAST, Dynamic Application Security Testing, that's basically you have to have a running application, right? It's running somewhere, maybe in the network, maybe in some staging environment, where you actually run your tests against that. And there are a couple of open source tools. There are also some other commercial tools that do that, and they're good. They're good, especially if you have time and specific budget to implement the automation suite. But also they have some potential issues. Actually, I worked with a couple of projects where they tried to implement automatic security testing against live server, trying to cast headers and security traffic and stuff like that. It was okay, but it was basically showing us what we already knew. It didn't find anything, anything that we didn't know, right? And that of course eventually was a waste of time.
You already knew you had security holes, and you said, "Oh, that's fine."
No, not like that. Yeah, we knew that there were some encryption issues with the past, but security holes, but it was protected by different means. Yes. Right. The other thing is CM, which I think is extremely important, especially now that I see what could happen when you work with normal users, is security information and event management. Basically, you have to collect all the audit information that's happening in your system. And I mean everything. Let's say if you're using Microsoft 365, you have to collect the audit logs. If you're using Jira, you have to collect audit logs. If you're using GitLab, GitHub, Bitbucket, whatnot, you have to collect audit logs and record it somewhere. Because if the breach happens, you would be very thankful that you can actually at least see something. You can at least detect something. Because quite often, I've been in this situation myself when we know that we were hacked, but we don't have information how and when and through which vector because we didn't have the logs. So I think if you want to do something to make your security at least to some extent better, collect information. Collect. And of course, there are many tools that that exist out there, like Splunk and Alk and Sentinel from Microsoft, and there are many others. It's not the only ones, but it's important to have them because, especially the bigger your company are, the more useful they will be. Right. And one last thing I want to mention, things that I really believe in. Is that, of course, I mentioned tooling and data that would kind of help you out. But the other thing is actually talking to people. And threats and risks, they have to be understood by the teams. They have to be understood by developers, by sysadmins, and other people. And for that, we have to do discussions. Right. Do you practice Agile? Anyone? Okay. There's like shy hands. Yes, we do. Okay, but do you do retrospectives? Okay, some of you at least. So do you implement everything after your retrospectives? Okay, so yeah, basically retrospective is a very valuable tool to raise the problems, raise awareness of what's happening right, what's happening wrong. And the same thing you can do with security. You can actually do security retrospectives. And that's what I'm actually advocating a lot for, because when we have the team of devs or sysadmins and we discuss the problems through, we discuss the potential attack vector, we discuss potential components that are involved in that, it appears that not everybody is aware of everything. Yeah, maybe your sysadmin with like 20 years of experience, they know everything, but not the developer and not the project manager and not the tester. They don't know everything. And security retrospective could bring attention to the problems first, and also it could allow to focus on the most important ones. That's what that's the problem with static analysis tools. With static analysis tools, you get lots of things, and not all of them maybe are in the context of your organization, of your project. But with retrospectives, with actual discussions, you can surface the things that actually are important and find the most critical path that should be protected. Right? You can actually use that as a priority setting tool. Right, and there are some models, some threat modeling or risk modeling tools that you can use to do that. One that I like is this guy, Stride. Spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. So basically, you take your system and you try to understand: do we have anywhere in our system potential identity theft risk? And you try to figure out whether you have it or not. Same thing with other ones, right? And you try to put maybe some scores within your team with security specialists inside the discussion and try to understand where is the most dangerous one, right? And then, this is just a framework for discussion. It's not really something that is like defined very well. Another one is DRAD, which looks at the security from a slightly different problem. This is a different angle. Sorry, it's discussing how much damage potential break in this part of the system can make, how easy it is to reproduce this kind of thing, how easy it is to exploit this kind of thing, how many users will be affected, right, and how easy it is to discover that they will have a problem in this specific case. Again, could be used to prioritize, because as I mentioned, if you run SaaS tool, you'll get lots of warnings, but maybe this model can actually help you find out which ones actually are the most important ones at this particular time. And actually, there are many more threat modeling, risk modeling tools or models or ideas that you can use. You can actually Google them. There's lots of them. But just to give you some glimpse of that. So basically, I'm using this threat modeling kind of exercises to find the maximum risk, and basically using the DRAD one. And my ideal state of a company that is security aware and that actually is having a proper culture to mitigate and manage security problems includes these elements, right? So first of all, we believe that security is everyone's responsibility. So there's no security team that only cares about security and no one else. No, that's not go. Everybody should care of that, and we should kind of facilitate and educate people on that. Of course, we have to use static analysis tools and dynamic analysis tools depending on the context. Because some of them could be good, some could be better, but still, because it's actually easy to use static analysis tools, let's use them. It's the easiest part. Definitely collect data. Definitely, well, maybe not definitely, but after some experience, try to do the anomaly detection. It's usually probably going to be like some commercial software for that, but it's definitely doable. Try to do this threat modeling exercises with your team. Try to see where potential risk, where is the biggest. Also try to plan the response for potential attacks, right? Because that's something that, like with backups. People do backups, but have never tried restores. The same thing could happen. Same thing is true about security. You have to also plan what will happen, what you will do, what's the protocol if you're breached. Who should be informed and stuff like that. And of course, yeah, do the security retrospectives with the threat modeling and without that. I mean, it doesn't really matter, but it's important to have these discussions and have some action plan after that. Okay, I think that's it. Thank you very much.
That's not it, because obviously we are here for the questions.
Sure, yeah, sure. I'm open to that.
Yeah, we'll start from there.
Yes.
Yeah, you mentioned like library analysis. What about vendor analysis? Let's say companies use tons of cloud software nowadays, and let's say use Okta or something else. And what happens if that platform gets hacked? You get somewhat a risk, but you may not be aware that they got hacked, and you have lots of these like softwares that get hacked pretty much regularly. How do you track these risks?
Well, I mean, first of all, of course, we have to trust to some extent our vendors and trust that they will disclose that something happened to them in time. And I mean, big companies like Google, Microsoft, Amazon, they will actually do that, and you know that they never hide things. But smaller companies, smaller vendors definitely can do that, and there's it's a matter of trust.
I mean, do you have a list of these software vendors that you use, or do you just rely on email coming to you?
Well, it depends on the size of the organization, of course. But of course, usually we have a list of software vendors that are allowed to be used, to whom we trust. But it depends on the size of the company. The bigger is the company, the bigger will be the list, and it's will be stupid to limit the list because then you can block the growth of the company. For smaller companies, it's easier because you can actually, we're using Microsoft, nothing else, or Google, nothing else. But with bigger companies, you can have, different departments and different branches of the same company. You cannot limit the list to some, predefined one. You have to allow some degree of freedom. And maybe, through some sort of education, some sort of facilitation, you can, set the rules that we trust the vendors that have, this certificates or this security standards and stuff like that, or they only work in Europe and stuff like that. We can define it on that level. We cannot define the list.
Okay, I guess I'm asking more about how do you get the information about the disinfection or attack? Because with popular vulnerabilities, you get it from the news.
Yeah.
With static analysis, you get it from some tool, but with these, some vendor getting hacked,
Yeah.
or maybe you use an API of somebody that gets hacked, and that can affect you somehow. Is there a way to somehow automate this or have some systematic overview of this information coming into you? You get a ticket, you investigate.
No, I don't think so.
Just word of mouth.
I don't think so. Yeah, word of mouth. I mean, you have to trust your vendor that they will notify you about the potential breach. But also, I mean, depending on how critical the service of that vendor is to you, you can also plan your security measures. Because, I mean, if you're sharing with them, some customer data, let's say if it's a payment system, then you probably have to verify that that vendor is actually PCI DSS compliant, at least. Because if they are, they will actually notify you. If they're not, well, then it's actually a fraud. you probably should not be using them for payments.
Andrey,
Yes.
you multiple times mentioned the word trust. Right?
Yeah, yeah.
Now, the question is, how do you define trust, or the rule for the trust? Like, how to identify that this company can be trusted?
Well, we can of course require them to pass some certifications, like ISO 27001 or the SOC 2 or something like that, and or actually be compliant with NIS 2, which is a new European Union directive. You can declare that as enough trust, and most likely will be okay. But again, as I mentioned, you have to also assess the risk of potential breach on the vendor. If it's just some weather detecting library, who cares if they hacked? I mean, I don't care. It's not the data that will break my company from doing stuff. But if it's like Microsoft, and we're storing our financial documents on OneDrive, of course I'm kind of caring about the files being stolen, and in that sense I know that Microsoft first of all cares about security, and you have like I don't know, $1 billion budget for security, so my gut saying me that I have to trust Microsoft, even though I'm not always trusting Microsoft, for example.
That's fine.
Yeah.
Andrey, but what about security vendors like LastPad, for example? They have data leakage. Will you continue to trust them if the company uses?
Yeah, that's a good question. After the breach, actually, I would trust them more than before the breach, because the breach mostly, if they're a really big company actually, and after the breach, they probably accumulated all the knowledge and actually fixed all the issues, and the next time they will actually be way more careful about different integration stuff like that. So I would actually say yes, after the breach I would trust them, because they will probably fix it. But should I trust them in general? Yeah, I don't know. That's a good question. You never know. You never know.
Flashing back to the previous question. So find a company who had security breach, and then start to work.
Yeah, yeah.
Right?
AI-generated code, how much trust?
No trust.
But it's used so widely. I mean, even everywhere.
I mean, it depends. That depends on the size of the code, right? And it depends on who actually verifies the code. Because if you give junior developer, like ChatGPT, and ask them to write something, they will write something with AI, and they will not be they don't have enough experience to verify that the code actually is doing what it's supposed to do. But if you give the same code to a senior developer with some experience, they actually could verify the code actually does what it expects to do, and then I would trust that code more than the one created by juniors. So, I mean,
If senior is a hacker, then it's done.
yeah. Yeah, we have to verify the code coming from AI. There's no other way. And I mean, you should definitely use AI, and I use it as well to write code. But I usually use it to write very small pieces of like small functions or very small scripts, or actually ask it to write unit tests for my code if I want that. But then, of course, I verify. I look at the code, and and I'm asking specifically what I want for the code to look like. You use this library, use this pattern, use this naming convention, stuff like that, and then I get what I want. Usually junior developers will not have the same knowledge as senior developers, and they will just say, generate me a script that does that. And yeah, hallucinations could be quite dangerous in there.
Claude can verify ChatGPT.
This melt spectrum is only theoretical, or it was exploited?
Which one?
This melt spectrum.
I haven't heard of exploits, like real exploits, but it was a pretty big thing that Linux kernel was patched like in no time, really, and was.
Yeah, but all systems run for a long time.
Maybe, maybe. And it's actually it's very hard to detect, right? Because there's no logging in CPUs.
There is a new week already, but
Yeah, the old machine is probably hackable, yeah. But the question is what's running on those machines, because the most dangerous thing of this Spectre meltdown is that you can see what's happening in the other process. And if there's some database encryption software running on that machine and you started another process, then you can probably get the encryption keys or something. That's dangerous. Or SSH keys or SSL interchange stuff. Yeah.
Probably there was some kind of point of decision because of the performance card of the future patches. They had to decide what's the more important from these machines, is it performance or security?
Yeah.
The
Question.
So you talked about supply chain security vulnerabilities, like brought examples, but didn't talk about mitigation.
Yeah, I didn't talk about mitigation. Yeah.
How do you mitigate?
Well, we actually create a plan, usually during the security retrospectives, we find which are the most critical attack paths, and we create a plan on Wiki. What should we do? What should be closed first? What kind of traffic? And usually it's like the minimal mitigation plan. We close some network paths, so it's not propagating further. Let's say we close user access to some websites, or we close access to the database, and we power up the maintenance screen, stuff like that. So usually the mitigation plan, at least initially, is very simple. We close the traffic. Then we try to figure out, get the logs from all the systems, maybe from some local aggregation system like Calc, and then we start analysis. So that's usually the mitigation plan.
That's just analysis of what happened, but you need to, further on.
Yeah, but if the hack happened, then something is definitely wrong. So you have to find what's wrong and fix it. But the mitigation plan is that we have to at least limit the damage. And the first steps is to block traffic, set the maintenance screen on the web app and stuff like that, so that we don't have more attacks. When we see spike in the traffic and we realize that something is definitely fishy going on, we have to block that thing, at least that IP address or that network segment and stuff. Usually, yeah, it's networking that is being protected in some way.
But the app may become fully inactive.
Yeah.
So you block real customers as well.
Yes. If we see that it's dangerous, then yes. I mean, it's better to.
And what if data was stolen?
If data was stolen, then yeah, it's a good question.
What if it's a hardware issue, or CrowdStrike? What would be the mitigation in that case?
Well, good question.
It depends.
It depends. Yeah, it depends. It really depends.
There's so many unknowns in
Yeah, exactly.
So, but definitely, as we are in the European Union, if data was stolen, you need to notify customers. For sure, about this one, in 72 hours, if I'm not mistaken, right? And
you have to notify users, have to notify customers. So yeah, it's important.
Do it nicely. You're famous now. You're saying to your client, you're famous. Just make it positive. Right?
yeah, not sure about this one. On this positive note, I would like to close today's talk. Andrey, thank you very much.
Thank you.
I guess the size. You can also choose one of these beautiful bottles here, and while you do so.